we're getting into objective 14. The other day we talked about objective 13, which was solving systems of linear equations by graphing. Objective 14, we are solving systems of linear equations by substitution. All right. So, to use the substitution method to find an exact solution of a system of equations, we must first write one of the equations in terms of x or y. Then we will have to replace that equation that says x equals or y equals. We will substitute that into the other equation for that variable. So in the past, we have seen situations where we had like x equals 2, and we plug that in for the other equation. So wherever we saw that x, we plugged the 2 in, and we worked it out to find out that y equals 10 or whatever. So what we're doing now, we are going to have x equals, and then we're going to have a variable expression, and wherever we see that x, we're going to have to plug in that whole expression that is saying that x equals. All right. So that's the main thing that you guys need to grasp for this objective. From there, we're going to be using all of the basics that we have previously talked about, from adding and subtracting integers, order operations, all of that stuff. You guys have to have that embedded in your hearts, because learning all of these new principles, we still have to continue to apply the old ones. We still need to remember that what we do on one side of the equation, we do on the other side. We still need to remember all of those little key fundamental components. Okay, so let's keep on going. Let's look at an example. So let's look at example 1. So with example 1, they're telling us to solve by substitution. So if you solve this by any other method other than substitution, the answer could be right, but because you did not follow the directions and do what was asked of you, it's technically wrong. Okay, so if you see a problem that say solve the systems of equation by any method or whatever like that, then you get to choose out of the 3 methods. But this one says by substitution. So that's something that I want y'all to pay attention to as far as for this next test, because we are looking at 3 different methods. I will be looking to make sure that you use the correct method to solve the equation. All right. So for equation 1, we have 3x plus y equals 5. For equation 2, we have 4x plus 5y equals 3. So the first thing we want to do is look at our equations, and we could actually solve either one of these equations for either variable, but looking at the easiest option, this y is already by itself, so we could just solve the first equation for y. If we do that, all we have to do is subtract 3x on both sides of the equation, and we'll have y equals negative 3x plus 5. All right. Of course, we could solve it for x, or look at the second equation and solve it for x or y, but it's easier because this y is not being multiplied by anything. We can just subtract the 3x from both sides and be where we want to be. Okay. Now that we have solved our first equation for y, now we're going to be working with equation 2 and 3. So we're going to call this equation 3. Okay. Now we're going to substitute equation 3 into equation 2. We cannot substitute it in equation 1 because that's the equation that we just transformed. So now we take equation 2, and where the y is in equation 2, we plug in what y equals. All right. So this y, where it says y equals this, we're going to plug that in for the y in our second equation, and it will look like 4x plus 5. Where that y was, we'll put in this whole variable expression, and then we still have our equals 3. Now this is where the order of operations and all that comes in. This 5 has to be distributed to the -3 and the +5, and we will get 4x minus 15x plus 25 equals 3. All right. Then we have to combine like terms. 4x minus 15x is -11x, and we bring the rest of our equation down. From here, we have -11x plus 25 equals 3. We need to get this plus 25. Remember, we're trying to solve for x. So we want to get x by itself. So the plus 25 is in the way, so we need to subtract 25 from both sides. So plus 25 minus 25 is 0. So we're left with -11x on the left side of the equation. On the right side of the equation, we have 3 minus 25, which 3 and -25 are alike. They're both whole numbers. So we can combine those to get -22. Now we're still trying to get x by itself. So we need to do the opposite of the operation that the -11 is doing with the x, which is multiplication. So we need to divide both sides of the equation by -11. And when we do that, -22 divided by -11 is +2. So x equals +2. So far, we took our first equation and solved it for y. Then, now that we know what y equals, we plug that into the second equation. Now that we have our equation set up to where the only variable in the equation is x, now we can solve for x, okay? With the equations the way that they are with two variables, we cannot solve for both variables at the same time. That's why we have to do the substitution, so that we have one variable so that we can just solve for that variable. All right. So now that we know what x is, we can take that x and we can plug it into equation 3. So this is equation 3 here. And I know that x equals 2, so I'm going to plug that 2 in for the x, and I'm going to solve it to find my y. So -3 times 2 is -6. We bring our +5 down, and we get y equals -1. So now that we know what x and y is, we have our solution. So that means the solution is an ordered pair, remember, because this is the point where these two lines intersect. So if we were to graph this, we would graph equation 1 and equation 2, and the point where both of those lines intersect will be our solution. But we are not graphing, we are using the substitution method. And with this method, we can find that exact point just by doing the calculation. So because we got x equals 2 and y equals -1, that means our ordered pair is 2, -1. All right? If you get these mixed up and you do -1, 2 is incorrect, okay? The x is 2 and the y is -1. So the answer is the ordered pair 2, -1. All right? All right, so let's look at another example. So key thing to remember with substitution, you taking one equation, solving for x or y, and you're going to plug that into the other equation and solve for that variable that's present. When you substitute it in, it should be only one variable that's present. So it shouldn't be a question of what you're solving for. All right, let's look at example 2. Once again, solve by substitution. Our first equation is 6x plus 2y equals 8. Our second equation is 3x plus y equals 2. So those are our two equations of the system. So if we look at equation 1 and equation 2, I think, I think that if we take equation 2, because this y doesn't have a number in front of it, it'll be easier to just subtract 3x on both sides. All right, so I think it'll be easier to take the second equation and solve it for y. So if we take equation 2, looking at example number 2 now, if we take equation 2 and solve it for y, we will get y equals -3x plus 2. All right. And I'll just show y'all again. If we take this second equation, this 3x is positive, so we have to subtract 3x from both sides. 3x minus 3x is 0, which is what we wanted because we wanted to get y equals blah, blah, blah. On the right side of the equation, we have 2 minus 3x. But that is not how we write it. Remember, we talked about that term with the x has to go first because of the degree and all that stuff that we're not really going to touch on. So instead of writing 2 minus 3x, it's -3x plus 2. You keep the sign that's with that item. So because the 2 is positive, it's plus 2. And because this is -3x or minus 3x, it's -3x. The negative sign and subtraction and positive and plus signs, they kind of go hand in hand. So the sooner you guys kind of grasp that with working with integers, the better off you will be moving forward. So now that we have equation 3, we're going to substitute the equation 3 in for equation 1. Once again, we take one equation, change it, and plug it into the other one. You cannot take our new equation 3 and plug it back into the equation that we changed in order to create equation 3. I hope that's making sense, okay? So we took equation 2, changed it, and now we're plugging it into equation 1. So we're taking equation 3 and plugging it into equation 1. So equation 1 is 6x plus 2y equals 8. And where that y is, we're going to plug in what we just said that y equals. So we plug that in for y. We have to do distribute. So 2 times -3. X is -6x. So we get 6x minus 6x. And 2 times 2 is 4. plus 4 equals 8. All right. From here, we have to combine like terms. 6x minus 6x is 0. So we have 4 left equals sign left, and the 8 is left. All right. Okay, so the way that we say that is 4 does not equal 8. Okay. So when we are solving systems of equations and we're doing the substitution method, and we see that substituting it in, it does not equal, then that means that it's no solution. Okay. And on this graph, they would not intersect. All right, let's work these out. With example 3, what's the first thing we need to do? Okay, so y'all want to solve the second equation for x or y. And when you guys are working these problems, this is what you have to think. You have to think about which equation you're going to solve and what variable you're going to solve it for. Y. Okay, so y'all want to take the second equation and solve it for y. So that means that we need to add x to both sides, and we'll have 4y equals x minus 3. Then we'll have to divide everything by 4. And we have y equals 1/4 x minus 3/4. Okay. So we can call this equation number 3. So since we took equation 2 and transformed it into equation 3, where do we plug equation 3 into? Equation 1. So we take in equation 1, which is 3x minus 2y equals 4. And we're going to plug in what we just said that y equals. So we got 3x minus 2. We're going to plug in that whole thing. And then we're going to rewrite everything else. From here, we have to do our basic, algebra, basic calculations. So we got 3x negative 2 times 1/4 x. All right, so we got negative 1/2 x. And we got positive 3/2. Just a side note, if I was solving this problem, I would have solved for the x in equation 2. That's what I would have did, because I would not have these fractions to work with. That would have been my preference. Now we need to combine the like terms. So 3x minus 1/2 x is 2.5x. Then we still have our plus, and I'll just make it 1.5 equals 4. And I'll leave it as a fraction. Let's do that, because y'all need to know how to do this anyway. So 3x as a fraction would be 6 over 2x. Then we got minus 2x. No, minus 1/2 x plus 3 over 2 equals 4. Which 4 is the same thing as 8 over 2. So 6 minus 1, that's going to be 5 over 2x. And then I'm going to have to subtract this on both sides because it's a plus. So that'll be 8 minus 3, which would be 5 over 2. Then when we divide both sides by 5 over 2 or multiply by the reciprocal, we'll get x equals 1. After we have x equals 1, we're going to plug that back into equation number 3, which is y equals 1/4 x minus 3 over 4. So when we plug that 1 in here, it's going to be 1 times 1 over 4, which is just 1 over 4. Then we have minus 3 over 4. So y equals 1 minus 3, which is negative 2 over 4, which is negative 1/2. Hopefully y'all still with me. This is the version that y'all chose now. So if it's too many fractions and stuff, this is the one y'all decided on. So our x is 1 and our y is negative 1/2. So that's our solution. I would have taken equation 2 and solved it for x. And it still would have been some fractions in there somewhere possibly, but it wouldn't have been like this. But this the answer. I mean, hey, you could take the first equation and solve it for x or y, or you can take the second equation and solve it for x or y. It's up to you. The more you work the problems, you'll be able to kind of just look at it and see which way would be the easiest way. So for example number 4, I'm going to pick 4, y'all, because that was a lot. So I'm going to take the first equation and I'm going to solve it for y. Remember in the previous examples that we did, I picked the term that did not have something multiplied in front of it. So I'm going to pick this y. So I'm going to write my first equation. 3x minus y equals 3. I'm going to subtract 3x on both sides. And I'm going to have negative y equals negative 3x plus 3. And when I divide everything by negative 1, I'm going to have y equals 3x minus 3. This is workable. This was a lot, okay? So you want to kind of try to think about that. So this is our new equation number 3. So I took equation 1 and I changed it to be our new equation 3, and I'm going to plug that into equation 2. So sometimes they may label the equation, sometimes they may not. If they don't and that works for you, then you are responsible for labeling it yourself. So I'm going to take equation 2. All right. And I'm going to plug in what equation 3 says that y equals. And I'm plugging that in for y. So we got 6x plus 3. And I'm going to plug in 3x minus 3 in for y. And then we got that equals -4. So we still got to distribute and all that. So we got 6x plus 9x minus 9 equals -4. 6x plus 9x, we can combine that to get 15x minus 9 equals -4. All right. Now we can add 9 to both sides. We get 15x equals, that's right. Okay, so we got 15x equals 5. So now we have to divide both sides by 15. So x equals 5 over 15, which can be reduced down to 1/3. So x equals 1/3. Now that we have x, we can plug it back into equation 3 because it's already set up as y equals blah, blah, blah. So we got 3 times 1/3 minus 3. Of course, 3 times 1/3 is 1 because it'll be 3 over 3, which is 1. So we got y equals 1 minus 3. So y equals -2. And because we have an x and a y, our answer or the solution is 1/3 -2. For example 5, they have done the dirty work for you already. The second equation is in perfect condition for substitution. So we don't have to rearrange or anything. We're just going to take what y equals on the second equation and we're going to plug it into the first equation. So this is best case scenario. They done already did the work for you. You just got to plug in what y equals, plug it in for that y. So it should look like 3x minus 3 times x plus 2 equals 2. From here we have to distribute. -3 times x is -3x. -3 times 2 is -6. And we keep our equals 2. We bring that on down. We have to combine like terms. 3x minus 3x is 0. And we have -6 equals 2 left. Which -6 equals 2 that don't sound right. That's mathematically incorrect. Therefore untrue. So for example 5, the answer is no solution. All right, example 6. I already set up. We're going to plug in that 2x minus 3. We're going to plug that in for this y right here. So we got 3x minus 2. For that y, we're going to plug in 2x minus 3. And then we're going to keep our equals 6. 3x, we got -2 times 2x, which is -4x, -2 times -3, which is +6, and then we still have our equals 6. We're going to combine like terms. 3x minus 4x is -1x. Then we still got our plus 6. Plus 6 equals 6. Okay. Then we need to subtract 6 on both sides. So we got negative x equals 6 minus 6, which is 0. And we can't have negative x, so we have to multiply both sides by negative 1. And of course, 0 times negative 1 is still 0. So now that we have what x equals, we can take that and we can plug it into the first equation because it's already set up so that we could just plug something in and get a y. So when we plug that 0 in for x, we get y equals negative 3. So because we have an x and we have a y, our answer is 0, negative 3. Let's quickly look at example 7. It's already set up perfectly as well. So we could just take the second equation and plug it into the first equation for y. So we got 9x plus 3. We're going to plug this in for y. We got negative 3x plus 4. Then we still need to keep our equals 12. Now we need to distribute. We got 9x. Okay, so we got 3 times negative 3x. So it's going to be negative 9x. We have 3 times 4. So that's going to be plus 12. And we're going to bring that equals 12 on down. Now we need to combine like terms. We have 9x minus 9x, which is 0. So we're left with 12 equals 12, okay? So 12 equals 12, is that a true statement? We have seen where we get an exact answer and we have a solution. We have seen where we get two things that don't equal and it's no solution. So what does it mean if we get two things that do equal? Ding, 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 that's it. When you guys are writing it, it's infinite and then it's leaf. All right, so I'm going to take equation 2 and I'm going to solve it for y because there's nothing in front of that y. If it was something in front of the y, then I'll have to divide everything by that number in front of the y and I will have a fraction. I don't want to work with fractions right now, so I don't have time for that. So I'm going to solve it for y. I am going to subtract 2x from both sides. I have negative y equals negative 2x plus 2. I can divide everything by negative 1 or change the sign of everything to get y equals 2x minus 2. Boom. This is my new equation number 3. Now I'm going to plug this in into equation number 1. We got 6x minus 3. I'm going to plug in 2x minus 2. We got our equals 6. Going to distribute quickly. And 6x minus 6x is 0. 6 equals 6. Okay, so once again, we got 6 equals 6, which means we have infinitely many solutions. Okay, so hopefully you guys got this. Hopefully I helped you kind of understand which variable to isolate based off of the ones that I think are easy to isolate. But you can isolate whichever variable you like. But just remember, the one that you guys chose, we had a lot going on. All right. So if we would have isolated this x, the problem would have been a little easier. So you'll still get the right answer, but it's a little easier if you isolate a variable that don't have a coefficient, which is the number in front of it. Okay? So I hope this has helped you guys. This is objective 14.